because we talked about this last portion already, how to visualize variables. So at this point, we are going to move on and talk about conditional statements. And I'm going to open a new tab so I don't lose track of the other way. New link. Well, before we talk about what conditional statements are, let's talk about why we need conditional statements. At this point, we can write algorithms already, except the algorithms that we'll be writing will be kind of boring and straightforward, literally straightforward, because all we can do is to change the value of variables in a sequential way. There's no way for me to say, well, sometimes I want to do this and other times I want to do that. Nope, I only got one choice. Whatever is next, I have to do it. Whatever is next, I have to do it until I run out of lines to execute at the end of the entire algorithm. You can do certain things with only really simple assignment statements like what we have right now, but not really a whole lot. Okay? A lot of times you need to have a way to make a decision. Do I want to do it this way or do I want to do it the other way? And to facilitate decision making, we need conditional statements. So that's why we are moving on to what we call conditional statements right now. So conditional statements allow a program to follow different paths depending on the outcome of conditions. In real life, do you make decisions on a daily basis, on an hourly, minute by minute basis? Yeah, we do. Yeah, we sure do. Okay. Tell me something that what was your last decision? Where you have a choice one way or another, you chose this way or the other. Yep.
Raise my hand.
Raising your hand, exactly. Okay, very good. Because you have a choice, right? I can choose to raise my hand, or I can choose not to raise my hand. So you have to make a decision, a conscious decision to say, okay, I want to raise my hand because I want to ask this question, or I want to make this point, or I want to answer the question from TAC. Okay, so we make decisions all day long. Consciously. Conditional statements is the kind of construct that gives programs or algorithms the ability to choose, which is a very, very important part of programming. All right, so we'll talk about conditions first. A condition is essentially a question that can only have one of two answers. Okay, it's either true or false. Okay, and my daughter and my son, is picking that up too. They like to give me answers that are not yes or no, sort of. Okay, a lot of times they would just answer my question with sort of. Did you like that soup? Sort of. Okay. Did you do your homework? Sort of. Am I upsetting you? Sort of. Okay. So in programming, we don't want answers like sort of. Okay. We want really, really black and white answers, and not even yes or no. We want answers like true or false. Okay. The rest of this slide, really just talks about why we don't want to use yes or no, because it is language dependent. Okay. It also depends on how you phrase the original question. Okay. So we don't want to deal with yes or no because it is ambiguous. We want to deal with just true or false in this class. Okay, so every question will look like this. Is it true or is it false that da-da-da-da? Okay, and the expression will either be true, yes, in fact, x is greater than y in this case, or it can be false, that no, it is false because x is less than or equal to y in this case. So every question that we ask in this case, in this class, in all the future classes in algorithm, you have to think in true, false, and not yes, no. I know some of you, yes, go ahead.
X equal y, that's not considered a conditional statement or the true false statement kind of deal that it's equal to. It's not true.
X equals y is a condition, which is also a question, right? So when you see x equals y in a programming class, then you should be thinking that it is a question. Is it true or is it false that x equals y? That is what you should be thinking when you see x equals y in programming. Okay? Because it's not stating that x equals y, it is asking, is it true or is it false that x equals y. So that's a big difference, between this class and any math class. Because in a math class, when you see x equals 5, it is a statement saying that x does equal to 5. Okay? Or a lot of times, it is saying that x does equal to 5. In this class, when you see x equals 5, it is a question. It is not saying that x equals 5. It is asking, is it true or is it false that x equals 5? Okay? So we'll see more examples like that later on. We know a lot of operators that can give us that sort of an answer, true or false. Greater than, is it true or is it false that x is greater than y? Less than. And we can go through these symbols pretty quickly, except I want to show you how to type these symbols if you do not have, if you don't want to deal with the HTML encoding of greater than or equal to. In most programming languages, we just use greater than and then followed by equal symbol to represent greater than or equal to. Because there's no single key on the keyboard that allows you to type greater than or equal to as a single symbol. Same thing for less than or equal to. Even though in HTML I can find the element to do it, when you're typing in a program, you just use less than and then the equal to represent less than or equal to. Not equal to is represented by exclamation point equal in C and C++. So in the next class, which is cisp300, you'll be seeing a lot of not equal to represented as exclamation point and equal to. So this applies to C, C++, Java, and most other C-derived languages, which would also include Perl. Okay, Perl is an example of a C-derived language. In the other family of languages, basically all the non-C languages, which include Visual Basic, SQL, Pascal, and so on, it is represented by less than or greater than. Because if you think about it, if x is less than or greater than y, it really is the same thing as x is different from y, which is also the same as x is not equal to y. So that's why in many other programming languages, not equal to is represented by less than greater than. Okay. Now I can also kind of explain why in C it is exclamation point equal to, because in C and C++ and also in Java, a single exclamation point means not. Okay, the negation of. So the negation of equal to means not equal to. So that's why it is using this particular representation in C and C++. Next one up is equal to. Okay, if x equals y, is it true or is it false that x equals y? And we all know the equal symbol. Now this is the part where you have to be careful, but not in this class, but in your next class. In C, C++, Java, and most of the C-derived languages, when you want to ask the question, is it true or is it false that this equals to the other one? You use two equal symbols and not a single one. Because if you use a single one, it becomes assignment. You have to use two to mean comparison. Okay? And then I can see someone is saying, but because the context is completely different. Okay? Assignment is an operation, evaluate the right-hand side, update the left-hand side. This is comparison. They should not be able to confuse each other because they should appear in completely different places of a program. In a normal programming language like Pascal or Visual Basic, yes, that is absolutely true. But in C and C++, that is not true. Okay? So you have to be careful about this one. I would say 60% of this class will be bitten by this particular problem in cisp300. Okay? 6 out of 10 of you will mistakenly use a single equal symbol when you actually should be using two equal symbols. And then the outcome is the compiler won't complain. The compiler would just say, if that's what you want to do, fine. Okay? But the program is not going to do a comparison. Instead, it will change the value on the left-hand side of the single equal symbol when you expect it to be comparing. Okay? And it will give you a completely different outcome too, depending on the actual value of the assignment. Okay, so you guys will find out next next semester what I mean by this. Okay, this is something best by experiencing it, not for me just talking about it. It's at least 60% of the class will do it, because I still occasionally do make mistakes like that, and it's really annoying too because it's really hard to catch. In most other more sane programming languages, in Visual Basic, SQL, and Pascal, comparing for equality is a single equal symbol, not a double equal symbol. In this class, don't worry about it, okay? Because as long as I understand what you mean, it's good. Okay. So in the next class, it is important to distinguish a single equal symbol from a double equal symbol, because your program will still compile, it just won't do what you think it should be doing. All right, next. Oh, wait, let me go back to the previous slide. Are there any questions about any one of these comparison operators? Greater than, less than, greater than or equal to, less than or equal to, not equal to, and equal to.
So what's the difference between a single equal and a double equal?
One represents comparison, which means the computer is asking the question, or it will be answering the question. Is the left-hand side, is it true or is it false that the left-hand side has the same value as the right-hand side when you use double equal to? When you use single equal in C and C++, then it becomes evaluate the right-hand side and then change the left-hand side to that value.
So the double equal is basically the computer asking a question.
It is a condition, yes. And the single equal is assignment, not a condition.
Okay, so x is equal to
X gets y. But you can put x gets y in a context where a condition normally goes in C and C++. Okay? The C programming language really should not be used as an instructional programming language, because it is known to be a programming language that leaves a rope long enough to shoot yourself in the foot. You can actually look it up. It's actually the title of a book. Yes. Okay, let me. Okay, C language, rope long enough to shoot yourself. And here's the book. Enough rope. Okay, I was not entirely correct, but pretty close. Enough rope to shoot yourself in the foot. Rules for C and C++ programming. Okay, so when you move on to the next class, cisp300, this may be a reasonable addition to your textbook. It will be helpful to you as long as you program in any language derived from C and C++. Okay? Sorry?
We're discussing the prices.
Oh, the prices?
Yeah, well,
26 used from a cent. Yes.
I don't know, we get most of our books off of Amazon still.
Well, most of
I don't waste my money at the bookstore.
yeah, this will be coming from a person who gave up programming altogether because of C and C++. I would assume. I mean, it's like, I don't want to see this book ever anymore. Just get rid of it. At dirt cheap price, right?
Should have given it to a library.
Hmm?
Should have given it to a library.